Okay, so here they have they are asking you why Kc in this reaction has no units. So see, there are 2 moles are on the reactant side and 2 moles are on the product side. So that's why it has no unit. So we will write over here as there are equal number of moles of reactants and products on both sides of equation. So all cancelled out. Is this clear to all of you? Yes, is this clear?
Yes, sir.
Okay. Now, have a look at this kind of a reaction. If you see in this reaction, a mixture of 0.02 mole of hydrogen and 0.02 mole of iodine was placed in 1 decimeter cube of flask and allowed to come to equilibrium at 650 Kelvin. So it's allowed to come to the equilibrium. So what are these moles? Are these moles are at equilibrium or at initial? Yes.
Sir, at initial?
At initial. So these are initial moles. Yes, Yusuf, Amna and Kubra, is this clear?
Yes, sir.
Now what they are saying, calculate the amount in moles of each substance present in equilibrium mixture. So we have to find at equilibrium. Okay, tell me, I have discussed it in the last class. Whenever we have to find the moles at equilibrium, what we will do? Whenever the moles at equilibrium are not provided, what will we do? Yes, who will tell me? Yes, Yusuf, Amna and Kubra, you all of you three were present in the last class. So tell me, what will we do?
सर तो इन सबका चेंज सेम होगा
Sorry?
इनका चेंज सेम होगा
Okay. Yes, who can recall what we do at first? How we'll do it? Whenever you don't know the moles at equilibrium, what we will do? Yes, who will tell me? Yes, Yusuf, you were there. Kubra, you were there. Amna, you were there. No one remembers?
सर इसके अंदर हमें इक्विलिब्रियम पे एक वैल्यू दी हुई थी इसलिए हमने चेंज निकाल लिया था इसमें कैसे करेंगे?
Okay, and what we call it? Yes, you are right. We will find the change. That's what we did in the previous class. So, if you guys recall, I have told you that whenever you have to find the moles at equilibrium, you always go for I stable, isn't it? Yes, Kubra, Amna, and Yusuf.
Yes.
Okay. So I stands for initial, C stands for change, and E stands for equilibrium. So it is I, then change, C, and then equilibrium. Okay, is this clear to all of you?
Yes, sir.
Okay. So if you see over here, how many moles of hydrogen are there?
One more.
One. And how many moles of iodine are there?
One.
And how many moles of hydrogen iodide are there?
Two.
2. So we can see over here the ratio between iodine and hydrogen iodide is 1:2. So it means if 1 mole of hydrogen iodide is, oh sorry, iodine is used up, then 2 moles of hydrogen iodide will form, isn't it? Yes, is this clear?
Yes.
Yes.
Kubra, your mic is not working. That's why I didn't hear you. Hamza, is this clear? Amna, is this
Yes,
clear?
sir.
So we got from this that whatever the moles of hydrogen and iodine will decrease, the double the moles of hydrogen iodide will form. Is this understandable to all of you?
Yes, sir.
Yes, sir.
Okay. Now, so they didn't provide us the equilibrium mole of any one of them, so we don't know what will be the equilibrium mole of any one of the reactant or product. Is this understandable? So
Sir, I have a question.
yes,
If the moles of hydrogen and iodine is not same in this situation, so what will happen?
we will take the ratio, simple as that. That's
Okay, okay.
we will look at the ratio, the balanced equation, that in what ratio they exist, we will follow the same ratio. That's it. Here the ratio is 1:1. If it's not, then whatever the ratio, we will follow that ratio.
Okay, sir.
Okay, so if we see, we don't know what will be the change, so we will assume, okay, look, if initially there are 2 and these are the moles of hydrogen and iodine and there is 0 mole of hydrogen iodide, so what do you think when the reaction will start, where it will proceed, to the forward or to the left, to the backward?
The forward.
Forward, very good. And if it happens forward, then it clearly indicates that the change in the reactant would be negative and the change in the product would be positive. Is this clear?
Yes, sir.
Yes.
Yes, Kubra and Yusuf and Amna.
Yes, sir.
Yes, sir.
Now, we don't know the actual what change will going to happen, but what we know, okay, there is a one issue over here. In such kind of a question, they always provide you the Kc value. So let me write over here that, okay, let me write over here Kc at 650 degree, sorry, 650 Kelvin is 59. Okay. So what we know from this balanced equation, that whatever the decrease in the moles of hydrogen, the same will be the decrease in the mole of iodine, isn't it? Because their ratio is 1:1. Is this clear?
Yes, sir.
Yes, sir.
Yes, Kubra and Yusuf.
जी सर.
So what I will do, I will assume that the change over here would be minus x. And if the change is minus x for hydrogen, then for iodine, what will be the change?
-x.
Minus x. Is this clear to all of you? If any one of you has any confusion, please ask. Yes, Hamza, Kubra, and Yusuf, is this clear?
Yes, sir. It's clear.
जी सर.
Yes, sir.
Okay, so if we relate or if we compare the ratio between one of the reactant and product, it isn't it? It's 1:2.
Sir, can you repeat?
Isn't it? It's 1:2, the ratio.
Yes, sir.
Yes, sir.
So if x moles of iodine is decreased, then 2x would be the moles of hydrogen iodide that will form because of the ratio is 1:2. Is this clear?
Yes, sir.
Yes.
जी सर.
Okay, now, so if I add them, here I will get 0.02 minus x. Here I will get 0.02 minus x. And here I will get 0 plus 2x, which makes it 2x only. Isn't it?
Yes, sir.
Now, from this equation, I can make the Kc expression. So the Kc expression would be Kc is equals to concentration of hydrogen iodide, and there are 2 moles, so it is going to be the power 2 divided by concentration of hydrogen raised to the power 1 as it's 1 mole times concentration of iodine raised to the power 1 as it's 1 mole. Is this clear?
Yes, sir.
Sir.
जी सर.
Okay, now what I'm going to do, I'm going to put the values. The Kc value at 650 Kelvin is 59. So 59 is equals to 2x squared upon 0.02 minus x and 0.02 minus x. So if I'll further solve it, can I write the denominator as 0.02 minus x whole square, and above I will keep it as 2x square. Is this clear to all of you?
Yes, sir.
जी सर.
Yes, Yusuf and Amna?
Yes, sir.
Yes, sir.
Okay. Now, what I can do, I can take the square root on both sides. If I do take the square root, what will happen? These two squares are going to cancel out with this square. Can anyone tell me the square root of 59?
$7.68.
So 7.68 is equals to 2x over 0.02 minus x. Is this clear to all of you?
Yes, sir.
Now, if I move the denominator to the opposite side, it will come into the numerator. So 7.68 is going to multiply by 0.02 and as well as with minus x. So can anyone multiply 7.68 by 0.02 and tell me the answer?
Zero 0.1536.
0.1536 minus 7.68 x is equals to 2x. So it will be 0.1536 is equals to, when minus 7.68 moves to the opposite side, it will become plus. So we will get 9.68x, isn't it?
Yes, sir.
Now 0.1536 divided by 9.68 is equals to x. So the value of x will be, can anyone tell me the answer, please?
0.015.
0.015. Is there
Zero.
any other number after 5?
Rate 6.
Okay. Is this clear to all of you?
सर x के दो आंसर्स नहीं हो सकते थे?
But that will be very difficult for you. So that's why we don't do it by quadratic. Instead, we will do this. So we directly get the change. Is this clear?
And sir, what about unit?
It's mole. It's the change in mole. That's it. X is the number of moles, isn't it?
Okay, sir.
So till here, is this clear to all of you?
Yes, sir.
जी सर.
Yes.
Okay.
Yes, sir.
So right now we got this x, we didn't get these values, right? So what I'm going to do, moles of hydrogen is equals to moles of iodine, which is actually going to equals to 0.02 minus 0.156. So can anyone tell me the answer, please? Yes, what will be the answer?
Negative 0.136.
Okay, it's not 0.016, it's 0.0156. Sorry. Now tell me the
4.14 exponent minus 3.
So it means 0.004 and it's 1, so we can just write it 0.004. Is it clear?
Okay, sir.
Yes.
Or you are saying 413, right?
Yes.
Now moles of hydrogen iodide. So it's 2x, right? So the change is 0.0156. So 2 times 0.0156. What will be the answer?
Zero 0.0312.
0.0312. So see, that's how we got the moles of hydrogen and iodine at equilibrium and hydrogen iodide at equilibrium. Yes, Kubra, Amna, Hamza, and Yusuf, is this clear?
Yes, sir.
Yes,
Yes,
sir.
sir.
जी.
Okay. Now after this, I'm going to give you another question. And that question you guys will be solving it, okay? So yes, here you go. You guys will solve it and WhatsApp me your solutions as soon as possible. And if you find any difficulty, please ask. You have to do both the parts, okay? Okay. Now have a look. Here again, we have to find the moles at equilibrium, and we don't know moles at equilibrium. So what we will do, we will make a ice table over here. But before that, in the first part, they have asked you to write the expression for Kc. So if and see over here, the Kc value is already given it to you. So the Kc expression would be Kc is equals to concentration of CO2 divided by concentration of hydrogen times concentration of hydrogen, not divided by. Both have the power 1 because there are 1 moles in the balanced equation. Then concentration of carbon monoxide and then concentration of water. Is this clear? Now, if you see all have 1 mole, so the change would be minus X for the reactants and plus X for the product. Is this clear to all of you?
Yes, sir.
So
जी sir.
0.40 minus X, 0.40 minus X, 0.20 plus X, and 0.20 plus X. Now Kc equation is already written over here. We now going to substitute the values. The Kc value is 6.4 exponent minus 1 is equals to, in denominator, in numerator, there is 0.2 plus X times 0.2 plus X. So isn't it? I will write it 0.20 plus X whole square because both of them are going to multiply with each other. Is this clear?
Yes, sir.
And in the numerator, as these two, as these two are going to multiply with each other, these two, so I'm going to write 0.40 minus X whole square. Is this clear?
Yes, sir.
Now, what I am going to do next, yes, what I am going to do next, I am going to take the square root. So I will take the square root on both sides. So on the right side, as there are, on the right side as there are squares, so these squares are got cancelled from the square root, and now on the right side we will have only 0.20 plus X over 0.40 minus X. Is this clear to all of you?
Yes, sir.
Can anyone tell me what will be the root of 6.4 exponent minus 1?
0.8.
0.8. Is this clear? Now, when we move the numerator towards, denominator to the opposite side, it will multiply it by 0.8. So 0.8 times 0.4, is it 0.32 or 0.032? Yes,
0.3.
0.32 minus 0.8x is equals to 0.20 plus x. So if I rearrange the values, it will be 0.32 minus 0.20 is equals to 0.8 x plus x would be 1.8x. So if you subtract these, you will get 0.12 divided by 1.8 is equals to x. So see here you did some thing wrong, Hamza. These values are not like this. Can anyone tell me the answer when you divide 0.12 by 1.8.
0.066.
0.066. So this is the value of X. So if you see, moles of carbon monoxide is equals to moles of H2 as both have same moles, 0.40 minus 0.066. And moles of CO2 is equals to moles of H2. You didn't mention these moles, Yusuf, initially. So it will be 0.20 plus 0.066. Can anyone tell me the answer? It's 0.266 and here, sorry,
0.334.
0.344, isn't it?
Sir, 334.
Okay, 0.334. So these are the moles of carbon monoxide and water at equilibrium, and these are the moles of carbon dioxide and hydrogen at equilibrium. Is this clear to all of you?
Yes, sir.
Ji, sir.
Okay. Now there is a one question that is a homework for you guys, and then we will start KP in the next class. Okay. So everyone just take the screenshot. Yes, are you guys done with the screenshot?
Yes, sir.
Yes, Amna, Kubra, and Yusuf.
Yes, sir.
Okay, so do send me before Friday's class, and we will start keeping the Friday's class. Okay.
Okay, sir.
Okay. Take care, everyone. Allah Hafiz.
Love is, sir.
Allah Hafiz.